Now that we have the bearing flats in place, you may be wondering about this axle that they show inserted here through the bearing flats. Well, that is going to be connected to the motor and then eventually to the wheels. So the next few steps are going to be to place that axle, bring the motor in, bolt the motor in place, and get ready for the wheels. So to do so, place. It's a motion component, it's a shaft. Now I believe a 3.5 inch shaft is long enough for this. 4-inch works, but it sticks out a lot at the end of the wheel. So we're going to start with a 3.5. We're going to place it near one of the axle spot locations down here in the lower front corner. And we can't really use eye mates on this. What we need to do is get it kind of close. And remember, in the 3D space, close is relative to your view. We need to constrain it. We will use an insert constraint, which is what most of our eye mates are. I need to zoom in and change my view. I want to see this front edge. And when I get the view that looks like this, a circle, and I can see the dotted center line and an arrow vector off the edge. Once I click it, I get what you see when you select one of our insert eye mates. I'm going to zoom back, change my view, and I'm going to zoom in to an edge of the bearing flat. Remember, this back hole is where the motor shaft will go. I am going to click whenever I see this edge, this circular edge right here, select it. Now, by default, it snaps it around like this. I'm going to change my solution to be the other way so that it's flush going back through it, and my offset to -1 inch. What that does is it pulls it through an inch. Now, had I had it like this, it would insert it an inch. Could have worked from that. Makes more sense to me to say how much you need sticking out of the hole, not how much it goes into the hole. I'm going to click OK. Now, the instructions showed you using a friction shaft collar. When we built ours, I recommended you don't use the friction shaft collars, that you actually use the metal shaft collars. So we're going to place the metal shaft collars on our model. I'll place it nearby. Okay. Now there are eye mates on it, and as we're going to be inserting it over that shaft, flush up against the metal, I am okay to start with those insert eye mates, just like this. Drag it, latch it in. Now that can spin around and rotate. So can the shaft. We need to lock them together, or it's really not much of a locking shaft collar. To do that, go to your constraint menu. Pick an angle constraint. Again, we'll do a directed angle, so we only need 2 vectors. I am going to select the screw. Let me zoom in so you can see what this looks like. It's going to show me 2 edges of the screw. Actually, the hole in the shaft collar in this instance. But I get the vector that points along the axis. So I select that. And then any of the edges, the flat edges of the axle. And it's going to line them up. I'm going to click OK. So now those 2 faces, that face and that unit vector always have to point in the same direction. And they are locked in place. I rotate one and the other rotates with it. Okay, quickly peeking back at the rest of the instructions. We need to bring a motor in place and lock it in with a 1/2 inch bolt. From there, we will place a 1/2 inch spacer on the other mounting shaft with a 1.5 inch bolt. So, zoom back out, go to place, and motors are in the motors folder. There's only one for this project. It's the V5 Smart motor. Place it in. It's in the wrong orientation. No big deal. Free rotate, spin it around, get it kind of close to what we want. Doesn't have to be perfect. But I do need to lock it into position. Notice how I have 3 inserts here. many ways to mount the motor. You really only need to use 2 of them. So, let me take the 2 here. We will be putting bolts in, and I mate them to these 2 holes here. So, hold my Alt key, snap it into place. Now, I got to be careful how I arrange the motor. You don't want to do this backwards. If you do, you can undo it. Ow. In fact, I should probably show you how to undo one of those, because I just put it in the wrong location. Those, I'm 1 hole off. So Control Z can work if it's the last thing you've done, but since I've changed the view a few times, Control Z isn't what I want. It'll just undo my view changes. I'm going to go to the expand the smart motor. I can see all the parts that make it up. But down here at the bottom, there's an insert. That's the iMate insert I just used. I'm going to right click and delete that insert so that I can move it. I need this to match up to this hole. So let me try it again. Alt. Locked in place. Line up the other one. Oops. Had the wrong one. Wasn't possible. My view's a little... Let's try again. There we go. Things look pretty good, don't they? And the only thing here, and this is being nitpicky. See how this shaft moves? I want that shaft to line up with the motor. So, constrain, angle constraint, side of the shaft, side of the motor, 2-directional. Click OK. Now the shaft doesn't move because it's locked into the motor. Now for some simulations, you actually want to have that tied into the motor. What you can do is the motor is an assembly of many parts. I'm going to right click on it, and there's an option called flexible. If I make it flexible, the motor was designed so that the gear housing in here can spin, and that will make it so that the motor, when it turns, your axle turns. Okay, we need a couple of bolts. The first one was a 1/2 inch. We haven't used a 1/2 inch yet. So back into the structure folder, find the 1/2 inch star drive, place it somewhere nearby, and just use the iMate to snap it into position. Now, I believe it was in this outer one. Now the inner one required a 1/2 inch spacer. The spacers are in the motion folder. Spacer, 0.5 inch. Place it somewhere nearby. Grab an iMate off the edge of it and lock it into position. That's the correct one there. I also need a 1.5 inch bolt. Back to the structure folder. 1.5. Zoomed in a little too much. Place it up here. There we go. Alt key and move it in. Not there. Not there. There it is. Now I've got my 1/2 inch bolt. Zoom out. We'll go back to the home view. That is beginning to look quite a bit like how our motors should look. Here you can see the finished product after I completed the same steps for the motor and the drive shaft on the other side. Now, I didn't create a component or a pattern because I didn't want the motor to lose its flexibility. And since it's a mirror image, a pattern wouldn't work in this case. There are ways to do mirror images, but with the motion we needed in the motor, this was the best way to just repeat the individual steps. There's not very many components. If you need to see how to do that, just rewind the video and look at how we did the first motor. Just do it on the other side. From here, we'll move forward to the next video where we will place the front wheels.